Welcome to this lesson on the laws of indices. In this video, we're going to build up the main rules you need when working with powers, step by step, and then apply them in a few examples. The key idea throughout is that an index or power tells us how many times a number or variable is multiplied by itself. Let's get started. So firstly, let's remind ourselves of what a power actually means. If we have something like 2 to the power of 3 or 2 cubed, that means 2 times 2 times 2. So the index tells us how many copies of that base we have multiplied together. This is the idea that all of the laws of indices come from. Our first law is multiplying powers with the same base. When we multiply powers that have the same base, we're going to add the indices. So if we had x cubed and we multiplied it to x to the power of 5, we would get x to the power of 8. And the reason for this is very simple. X cubed means 3 x's multiplied together, and x to the power of 5 means 5 more x's multiplied together. So altogether we have 8 x's multiplied together, which gives us x to the power of 8. The important condition here is that the base must be the same. If the base is the same, we can add the powers together. The second law is dividing powers with the same base. When dividing powers with the same base, we subtract the indices. So if we had a to the power of 5 divided by a squared, we would get a cubed, or a to the power of 3. Again, this comes from writing everything out. A to the power of 5 means 5 a's multiplied together, and a squared means a times a. Because we have an a squared in the numerator and the denominator, we can cancel these out. This leaves us with 3 a's, so the answer is a cubed. So for division, the same base means we can subtract the powers. The third law is the power of a power rule. When we raise a power to another power, we multiply the indices together. So something like b to the power of 5 all squared becomes b to the power of 10. Why? Well, because b to the power of 5 is 5 b's multiplied together. If that whole thing is squared, it means that we multiply the expression by itself again. So in total we end up with 10 b's multiplied together. That is why the powers multiply. Now let's talk about zero powers. Any non-zero number raised to the power of 0 is equal to 1. This often feels strange the first time you see it, but it follows directly from the division rule. If we take something like x to the power of 5 and we divide it by x to the power of 5, the answer must be 1, because anything divided by itself is 1. But using the laws of indices, x to the power of 5 divided by x to the power of 5 is x to the power of 5 minus 5, which is equal to x to the power of 0. So x to the power of 0 must be equal to 1. This is where the rule comes from. Next we have negative indices. A negative power does not mean that the answer will be negative. Instead it means that we take the reciprocal. So a to the power of minus 1 simply means 1 over a. This also comes from a pattern within powers. For example, if we go from a cubed to a squared, to a to the power of 1, to a to the power of 0, each time we're dividing by a. So if we continue on this pattern one more step, a to the power of minus 1 must be 1 over a. So negative powers means the reciprocal. Let's do a quick example. Simplify 3 squared times 3 cubed all divided by 3 to the power of 4. From BIDMAS we know that we need to deal with the bracket first. We need to simplify 3 squared times 3 cubed. Well, from the multiplication law we know we can add the powers together. So 2 plus 3 equals 5, so we have 3 to the power of 5. Now we're left with 3 to the power of 5 divided by 3 to the power of 4. We're left with the division law, so we need to subtract the powers. 5 minus 4 equals 1, so our final answer is therefore 3 to the power of 1, or just 3. We can now look at a slightly harder GCSE example. Simplify 12x to the 7 y to the 3 divided by 6x to the 3 y. Straight away we should write this as a fraction, as it's just going to make it easier for us. We should think about what factors we can cancel from both the top and the bottom. Well, we can divide the 12 by the 6 to get a 2. Using the division law, we can subtract the powers on both the x's and the y's. After doing all of this, we can write our answer, which is 2x to the 4 y squared. Finally, let's look at fractional powers. Fractional powers are really just another way of writing roots. For example, a to the power of m over n. The n here indicates what type of root we will have, like a square or a cube root or any other degree of root. The m is just a power that the a is raised to. So take x to the power of a third, this just means the cube root of x. So here's a typical GCSE example. Find the value of 27 to the power of 1/3. So 27 to the power of a third is the same as writing the cube root of 27, which is just 3, since 3 times 3 times 3 is 27. And that brings us to the end of this lesson on the laws of indices. Thanks for watching, bye bye.